All right, today we're doing something a little different. We're not just looking at a piece of software, we are going full-on forensic. We're going to crack open the digital blueprints of a system called Graph Manifold to figure out how it thinks, how it was built, and, the really big question, why it was built this way. So, let's get our tools out and start the investigation.
See, our source material for this isn't some glossy marketing page. No, we're diving straight into the project's own guts, the files right out of its /docs folder. We're talking raw architecture diagrams, developer logs, even their philosophical manifestos. Think of us as digital archaeologists, and these documents, well, these are the artifacts we're about to uncover.
So first things first, what is Graph Manifold? Okay, that definition is a mouthful, but at its heart, it's a system for finding and piecing together knowledge in a superstructured, repeatable, and predictable way. And that word deterministic, that's the key. This whole thing is built to avoid guesswork. It's designed to give you consistent, traceable results every single time. No surprises.
Now, to get how it pulls that off, we've got to start right where the developers did, the core architecture. And pulling this straight from their architecture.md file, we find this foundational concept they call the three-manifold blueprint. This is the bedrock of the entire system.
Okay, the word manifold sounds pretty academic, right? But the idea behind it is actually super elegant. Just imagine you have 3 workbenches. They are absolutely identical. Same tool layout, same organization, everything. Now, one bench is for your personal stuff, another is for, say, library books you've checked out, and that third one, that's a temporary spot where you bring things from the other 2 to work on a specific project. That, right there, is a manifold system.
And here they are, those 3 workbenches laid out for us. The identity manifold, that's your personal stuff, your session history, your context. The external manifold, that's the giant public library of knowledge. And then there's the virtual manifold. That's the temporary workbench, spun up for just one query and then poof, it's gone. This is where the magic really happens.
And this quote, this reveals the golden rule of the entire system. Let's call it the same schema rule, because all 3 of those manifolds have the exact same structure, same kinds of nodes, same kinds of edges. The same piece of code can operate on any of them without a hitch. This one simple rule is what makes the whole system so clean and so powerful. It's genius, really. Okay, so we've got the static structure, the 3 workbenches, but how does the assembly line actually, run? Let's follow the data and look at the system's processing pipeline. This is how a simple question gets turned into a fully formed answer.
It's a beautifully clear 6-stage assembly line. First, it projects. It grabs slices of data from the permanent manifolds. Then, it fuses them together into that temporary virtual space. From there, it scores everything for relevance, extracts the absolute best pieces, hydrates them with all the details, and finally, synthesizes the answer. It's just this methodical, logical flow from raw data to refined knowledge. Now, one of the key things that comes out of this pipeline is something called the evidence bag. And the name itself tells you so much about the system's philosophy. This isn't just a jumble of text snippets. No way. It's a subgraph, a literal piece of the knowledge graph itself, with all the original relationships and connections still intact. It keeps the context, and as we know, context is everything.
So how does it decide what the best evidence is? Well, during that scoring stage, it uses clever equations like this one, the gravity formula. It's basically calculating a score for every bit of information by balancing 2 things: how important it is structurally within the graph, how connected it is, and how relevant it is semantically to your actual question. It's a slick way to find stuff that's both popular and perfectly on topic.
An architecture this clean, this logical, it doesn't just happen by accident. When you dig into their dev docs, especially files like devlog.md and extractionrules.md, you find this incredible story of discipline. This system wasn't just built, it feels like it was meticulously crafted. So it turns out the developers were moving away from an older system. But instead of a chaotic, all-at-once rewrite, they used a really smart approach called the Strangler Fig pattern. And this quote from their own rulebook says it all. The old code was just source material to be studied, not a body to be transplanted. What a great way to put it.
And boy, were their rules strict. You could pull out a small, pure function or maybe a single, self-contained algorithm, but you were absolutely forbidden from copying an entire file or anything that touched multiple parts of the old system. This kind of discipline is how they kept the new system clean and avoided inheriting all the mess from the past. And that discipline carried right over into the new system's design. A file called systemmap.md basically acts as their constitution, laying down these super clear boundaries.
For instance, the part of the code that does math is forbidden from making network calls. The part that creates manifolds isn't allowed to touch the data operations. Every single component has one job and one job only.
And if you look through their developer logbook, the devlog.md file, you can actually watch this step-by-step construction happen. You see the system just evolve phase by phase. First, they build the skeleton, then it gets a memory. Then it learns how to rank things, and finally the whole assembly line gets connected. It's a masterclass in building software methodically.
Which, of course, brings us to the biggest question in our whole forensic investigation. Why? Why this obsession with structure, with rules, with discipline? Why go to all this trouble? The answer, it turns out, isn't in the code. It's in their philosophy.
And for that, we turn to this absolutely fascinating document we found in the /docs folder called translationtheory.md. This file is the key. This is where the developers lay out the huge idea that drives this entire project. And here it is, the big insight. The system doesn't just store data, it translates it. When it takes in a document, it projects that information into multiple different dimensions or spaces. One space maps out the document's structure, another maps its semantic meaning, a third maps all its relationships. It's like creating multiple different kinds of maps for the exact same territory.
And this is where the magic comes from. The system does all its heavy thinking in these abstract mathematical spaces. But, and this is so important, because it always keeps a link back to the original source, its conclusions are never just floating in space. It can operate in this world of pure relationships, but it can always point you back to the exact sentence in the original document where it got an idea. That's the translation loop.
So, what's the endgame here? What's the ultimate payoff for all this architectural rigor and deep philosophical thinking? What does a system like this actually build?
The payoff is this simple, powerful idea. The structure of the data, the form of the graph, is its function. The way you choose to connect your information literally defines the kind of thinking you can do with it. If you build a different kind of map, you can ask different kinds of questions and find totally new insights.
Which brings us to this final, just profound line from their theory document. This entire, disciplined, incredible effort. It was never about just building a better database. It was about building a translation lattice of meaning spaces, a machine for turning raw information into structured, computable, and ultimately understandable knowledge.
And that leaves us with a really fascinating thought to chew on. If we can represent our knowledge based on its structure and its meaning and its relationships, what other dimensions, what other meaning spaces are still out there just waiting for us to figure out how to translate our world into them? Thanks for digging through the blueprints with us.